Another LeetCode assessment today. It's going to be random 2 questions, and this is my current stats. So yeah, let's get started. Okay. So the first problem is given an array prices where prices I is a given stock in the ith that you want to maximize your profit by choosing a single day to buy one stock and choosing a different day to buy another or sell the stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay. So this problem can't be solved with DP because the constraints are too high to keep track of the last visitor value. So this has to be like more greedy based problem. So here if we see we buy the stock on day 2, and if we buy a stock we can sell it on any day, right? And we can okay. So it's just a simple pretty solution. So let's do int bot stock equals currently 0 and max equals 0. Int max 0 is less than prices dot length or the size. Okay, I plus plus. Now if prices at I is less than prices or bought stock, the previously bought stock, then we can do bought stock equals prices at I. Else max equals max between max or prices at I minus bought stock. And then we can return the max. The reason I'm doing this is if we see a stock that's less than what we bought, right? There's no need of selling it because we can just use this value in future values or future stocks. So yeah, you can't sell the stock either way, so just you have to update it. So let's see the second question. Given an integer norms, return an array answer such that answer at I is equal to the product of all the elements. Okay, product of any prefix or suffix is guaranteed to fit 32-bit integer. You must write an algorithm that runs in O of n time and without. Okay, so using the division operator, it just basically tells us we can't do, or yeah, it's obvious because if we do a brute force approach, that would give us TLE. Follow. Can you solve this problem using? Okay. Let's just try to consider the follow up, and then that runs in O of time without using any division operation. What is that? Operation. Okay. Oh, I guess you can just like divide it by these numbers or something like that. Product of all elements except okay, let's think. If we use a prefix and suffix array, that would not guarantee a solution where there's O of 1 extra. Okay. If we use a prefix and suffix approach, we need another array, which would not make this solution O of 1, and then we cannot use the division operation for some reason. Okay, let's see. What would be the best approach to solve this problem? Hmm, thinking of using like prefix sum, but I think that would work because we can't get the suffix without creating a new array, so that just makes it difficult. Okay, let's see. Extra O1 extra space complexity. The output array does not count as okay. Oh wait. The output array does not count as oh. So first of all, let's just create a vector int ans, right? This doesn't count as a towards the space complexity, so let's just create it like this. Now we want to first of all like how do we want to do this exactly? I mean, get the sum and then we can get the prefix product without any issues. It's just about the suffix. So if we get the prefix, right? Let's do this, okay? Basically, I think this is simple. So for now, let's create an as equals 0 and then go through nums, right? From left to right. And then we want to do answer I equal, wait, this is product equals product times numsI, and then after that we set the product equal to 0 also. Now we reverse this time, so it starts from nums to size minus 1, I is greater or equal to 0, and then we do answer I equals product, okay, answer I equals answer of I multiplied by product multiplied by nums at I, and we return ans. Let's see what this does. Okay. Yeah, wait. So just gives an error, okay. I mean, oh, we also have to, okay. Product at I, or we all have to update the integer product equal product times nums at I, nums at I, and then product times nums at I. $24. Oh, here the product, but it's saying except itself. Okay. So since it says except itself, we have to start from 1, and answer I equals product. This has to be 1 then. Equals product times nums at I minus 1. Okay, and then product, okay. Now we need to start from I minus 2, and then product. Okay. Answer I equals multiplied by product. This is not nums at I, and then nums at I equals product times nums at I. No. I'm sorry. I don't know why it's giving me error. Or like the wrong answer, my bad. So each time we're saying answer I equals product times nums at I minus 1, so for 2 it becomes 1. And then for cool, now we start from I minus 2 and then do answer I equals answer I multiplied by product. Okay, let's do answer I. 1, 2, 6. Okay. Dude for out. Oh, this is not okay. This has to be I plus 1. Okay. Does this go before we process our value? And then we do the same. Okay. Actually, okay, now it works. So if we do it on this test case, I feel like this should work. But it has negative numbers, so it might. Okay, so if we try submitting it, let's see if it works or not. Okay, it works. Let's try to finish our session and see what we got. It might take a while. The second problem was interesting. It was a meeting problem, but let's just wait for a moment. Okay, 7.83 out of 10, and then if we go to my overview, it's 6.37. We're still increasing, so yeah. So overall, it was a good assessment, and I'll see you guys on the next video. Bye.